Hello everyone, today I am going to discuss quick sort algorithm, and we will see a code to sort an array in C++ language. So suppose we have an array 4, 6, 2, 9, 3, 5, and we have to sort this array through quick sort. So first step is that we have to select an element that is called pivot element out of this array. There are several ways of selecting the pivot element. We can randomly select any element uh, to as a pivot element, and we can select the first element as pivot element, or we can select last element of the array as pivot element. Here we are going to select first element as a pivot element. So we have selected 4 as a pivot element. So our next step is that we are going to place 4 in its correct position. By correct position I mean that 4's position in the final sorted array. So we'll put it here in between, and to do so, to find the correct position of 4, we will place all the elements that are smaller than 4 before it, and all the elements that are larger than 4 after it. So here 2 is smaller than 4 and 3 is smaller than 4. So we will write in the same order as they are in the given array, and 6, 9, 5 are larger than 4. So we will write after 4 6, 9, 5. Now we have this array. So this is called partitioning. 4 has already come to its correct position, and we have two arrays, that is left array and right array. So we will make a recursive quicksort call on this array left part and this right part. So again it will be partitioned. We will select 2 as a pivot element, and we will place 3 after it, as 3 is larger than 2. And similarly here this is the right part is empty, only left part is present. Here we will select 6 as pivot element, and as 5 is smaller than 6, it will come before 6, and 9 is larger than 6, it will come after 6. So we will have an array like this. This is the right part and this is left part. So only one element is left in right part and left part. So as we know that one element, if array contains one element, the array is sorted. Similarly here only one element is left, so it will be considered as sorted, and we will hit the base case here. So after doing all these operations, we will get our final sorted array. So we are going to implement quicksort algorithm in 2 steps. First step is partitioning. Second is recursive call. We will make a separate function for partitioning the array, and we will call recursion in quicksort function. Now let us see code to implement this quicksort.
Now let us see the code implementation of quicksort function. Here I am defining an array int ar. It's containing some elements in random order: 98, 67, 56, 43, 23, 11, 9, 5, 1. Now finding out the length of this array, that is equals to size of array divided by size of int. Now calling quicksort function to sort this array. Quicksort. Here we will pass our array starting index, that is 0, ending index of this array, that is length minus 1. After calling the quicksort function, our array will get sorted. Now to see output, I am putting this for loop that will run from 0 to length of the array, and we will do here cout array I and some space. Now we will write our quick sort function. It's not going to return anything, so its return type will be void quick sort. It will have three parameters. First parameter will be integer type array, and second parameter will be starting index, third will be ending index. It's going to be a recursive function. So first we will discuss its base case, that is, if starting index becomes greater than or equal to the ending index, we will simply return. Because if starting index becomes greater than or equal to the ending index, then either our array is containing only one element or it is empty. In both the cases it's already sorted, we need not to do anything, we will simply return. After that we will find the index of the pivot element, so we will name it pivot index. That will be written by a function partition that we will write later. It will take array, starting index and ending index. After that this partition function will find the correct position of the pivot element. By correct position here I mean that its position in the sorted array, final position in sorted array, and it will put all the elements that are smaller than the pivot element before pivot element, and it will put all the elements that are larger than pivot element after the pivot element. So it has actually made partition in our given array. So we have now two arrays, that is left part of the array and right part of the array. So we will call quicksort recursively on these two parts, and they will get sorted. So calling quicksort on the left part, quicksort array starting index till pivot index -1 will not include pivot index because the pivot element is already at its correct position. So quicksort array pivot index +1 to an index. Now left part and right part will also get sorted, so our whole array will get sorted. The only thing that is remaining, that is partition function. Now we will write partition function. As partition function is going to return an index of the pivot element, its return type will be int, then name of the function partition, it's going to take three parameters, first array, then starting index, then ending index. After that we will find the pivot element. So pivot is equal to, it's going to be the first element of our array, so we will write array starting index. After that we will count how many elements are there in our array that are smaller than this pivot element. So we will maintain a variable count here. Now running a for loop from the element next to the starting element of the array. So starting index +1, so I less than equal to till ending index of the array I plus plus. If element array becomes less than pivot, then we will increase our count. After that we will can find out the position of our pivot element. Let's name this position pivot index. It's going to be starting index plus count. So now we are going to swap the element that is present within, that is present at pivot index, with the starting element. Int temp is equals to array starting index, array starting index is equals to array pivot index, array pivot index is equals to temp. Now one thing is left. We have to move all the elements smaller than the pivot element before the pivot element, and similarly all the elements larger than pivot element after the pivot element. So to do so, I am declaring here two pointers. I will point to the starting index and j will point to the ending index, and I will now run a while loop till I is less than pivot index and j is greater than pivot index. Now inside this while I will put two while here. If array I is smaller than pivot, means that that element is at its right position, so we need not to do anything, we will simply increase our I counter. Similarly, we will check if element of array at jth index is greater than pivot element, then we will simply decrease our j counter. If our control comes out of the both while loop, then it is it is obvious that I is pointing to the element that is larger than pivot element and j is pointing to the element that is smaller than the pivot element. Now we will swap these both elements by checking this condition again. So here we are going to swap in temp is equals to ari and arj, we are going to swap ari is equals to arj, arj is equal to temp. After this we will return pivot index from our partition function. Now our partition function is also completed. Now we can save and run our program to see the output. So running it, so it is showing the sorted version of our input array, so it is working fine. Hope you understand the concept of quicksort. Thank you.